Hi everyone, and welcome to another episode of How to Make a Platformer in Godot. In this video, we're diving into 2D platformer movement. We'll start by adding a few platforms to our level, add basic platformer movement, and then add small tweaks like acceleration, input buffering, and coyote time to improve the overall feel of the controls. Godot 4.4 is finally released, so that's of course the version I'm using for this video. The project files for this tutorial are, as always, available through selected tiers on Patreon. And now, let's get started. Right now, I just have a blue background and a separate scene for the player, but the player can't move or anything. The player has an animated sprite with an idle animation that's played when we run the project. It also has a collision shape that we'll be using when we handle collision with the platforms in this episode. Please make sure that your player sprite is roughly centered around the origin here and that it matches the collision shape. If you need help on how to set up any of this, then please go check out the first episode in this series on how to make a platformer in Godot. Before we can run around and jump, we need a few platforms we can jump on. In a later episode, we'll see how we can create lots of different platforms using the Godot tilemap system, but since this video is mainly about movement, we'll create a simple platform scene instead and use this to test our movement. So let's create a new scene for the platforms, and the root node here should be a static body 2D. Remember that the character body 2D node we used to create the player needed a collision shape to function properly. Well, this is also the case for the static body. So let's add a collision shape as a child of the scene's root node. This is also a good time to save our new scene. It will probably also be a good idea to make sure that the player can see the platform. For the purpose of this video, we'll just have platforms with a single color. To add this, we can add a new node called colorRect as a child of the platform scene's root node. As the name suggests, this will add a rectangle with a single color to the scene. To change the color, we can select the colorRect node and locate the color property in the inspector menu. If we click the color already assigned to it, a new menu will appear from which we can change the color. I'm making my platforms red to make them pop a bit when we test everything. Finally, we need to make sure that the size of the colored rectangle and the size of the collision shape match each other. Back in the scene for our test level, we can then click and drag the saved scene from the file system menu and either into the scene tree or directly onto the view here in the middle. We can then change the size of a platform either by choosing scale mode up here and scale it in the view, or by locating the scale property in the inspector menu and change it here. I'm using this to create a large platform as the floor of the level, and then also a few platforms over the floor so we have something to jump between. Before working on movement and collision, I quickly want to make the level just a bit more fun to look at by adding a background or two. I've already added a back and a middle image from the Sunnyland asset pack to my project. And then I'll add a new node called textureRect to the root node of our level scene. This will just create a rectangle displaying a texture. The texture we want our new textureRect node to view is the back.png. We can set this by locating it down in the file system menu and then click and drag it onto the textureRect node we just created. I'm using the same method to add a few middle layers. And then we can scale and move it all around until we get something we like. Note that by default, the textures will be rendered in the order they're listed in the scene tree. This is just how we'll be drawing the background and middle layer for now, but We'll also be looking into parallaxing in a later episode. Now that we have the first few platforms set up, we can finally start working on the player's movement. For this we need a script for the root node of our player scene, so let's open our player scene and create a script for the root node. To create a new script and add it to a node, we can just right-click on the node and select Attach Script. We can then create either a blank script or use a template. The character body 2D, which is the type of our player's root node, has a basic movement template that we can start out with. However, for teaching purposes, I feel that it's better if we create a movement script from scratch ourselves. Not only will it help us understand what we do and why, but it will also end up with a structure I feel is easier to expand on afterwards. So make sure the template is unticked and hit Create to create the script. This should open up the script menu, and here we should have an almost empty script. The first thing I'll add to our script is two new methods. One is the physics process method that takes a float as input. This is a built-in method that Godot will run every frame. Next, we'll create a new method to handle input. And then call this new method from the physics process method. Now our handle input method will also be called each frame. Before we can move our player character, we need to know if the player has pressed any of the movement keys. Since we only look at left and right movement, we can use the input.getAccess method for this. This takes two input actions as input. An input action can have a key press, mouse movement, and similar input from the player connected to it. Here we're using the UI left and UI right actions for our movement. These are by default connected to the left and right arrows on the keyboard and to the left and right movement on a joypad. You can add new actions and set what input events they're connected to in the project settings, but we won't dig deeper into this in this video. The input.getAccess method will return a value between -1 and 1. Let's store this in a new variable called direction. If the left input key is pressed, then the value will be negative, and if the right key is pressed, then the value will be positive. If either both or none of them are pressed, then this value should be 0. To update the player's velocity, we need to have a speed variable that defines the speed the player should move with. So let's add an exported speed variable at the top of our script. When we make the variable exported, a new property will be added in the Nodes Inspector menu. This way, we'll be able to set the player's speed not just from the script, but also from the inspector menu. With our new speed variable, we can then update the player's velocity to be the direction multiplied by the speed. The last thing we now need to get our player moving for the first time is to call the move and slide method from the physics process method right after we handle the input. This method is a part of the character body 2D class, so it can't be used if the root node of our player scene is of another type. I've had several comments on the video I made about movement in my action RPG series that said that we need to also add the delta variable to the velocity here to make the movement frame rate independent. I just want to point out here, like in the comments to the other video, that this isn't true when we use move and slide to move the player. The move and slide method automatically includes the timestamp in its internal calculations. I've left a link in the description to where you can read more about this. Now let's test the project and see how this works. Okay, there isn't any gravity yet, but the player is moving. But what about the animation? We don't want to show the idle animation when we move left and right. So let's go back to the player scene, select the animated sprite node, and down in the animations menu, we can then add a new walk animation. How to create a new animation from a sprite sheet is covered in the last episode of this series, so please go watch that if you need any help here. I'm creating a walk animation using the second row of sprites in the sprite sheet. And while we're here, let's also create a jump up and a jump down animation. These will each just have one frame from a sixth row of the sprites. Remember to check your spelling here, as the animation names will have to match correctly when we play the animations from the script in a minute. Okay, so now I've added one animation for walking, one for jumping up and one for jumping down. Now let's go back to the player script and add a new method for updating the animation. This should be called from the physics process method just before we call move and slide. We also need to add an onReady variable with a reference to the animated sprite node from the player scene tree. We can get the path by clicking and dragging the node into our script. In our update animation method, we then first want to check if the movement in the horizontal direction is 0 by checking if velocity.x is 0. If this is the case, then the player is moving and we should just play the idle animation and return. If this isn't the case, then we need to play the walk animation. But remember that we only added one walk animation. This means that we should flip the animation if the player is moving to the left. We can do this by setting scale.x to -1. However, instead of adding an if-else statement here to check what direction the player is moving, we can use the sign method instead to get the direction of the x velocity and use this to set the scale. Make sure you do this before playing the walk animation. Now, if we test again, the animation should update correctly. If you feel that the speed and the animation don't really match, then you can go back to the walk animation and change the frames per second until you find something you feel fits your game. I've quickly cheated a bit and moved the player a bit down, so it looks like it's walking on the floor. So now we have left and right movement, but changing directions can feel a bit sudden. What a lot of games do to smooth the transition a bit is to add some sort of acceleration and deacceleration to the movement. So let's see how we can add this. First, we need an exported variable for the acceleration. This should be an integer. And now I can see that I made the speed a floating point value, but this should also be an integer. For now, I'll be using the same value for acceleration and deacceleration, but you can also have separate values for the two. To really get a feel of what this does, I'm starting out with a low-ish acceleration. Now let's go back to our handle input method. Instead of setting the velocity directly, we now want this to be changed using the acceleration. And Godot has a handy method called move toward that we can use for this. Let's first handle if direction is 0, which means that either none or both of the movement keys are pressed. The move toward method takes 3 inputs. First, the value we're starting at. This will be our current x velocity. Then the value we want to move towards, and this will be 0 because we want to stop moving. And finally, the last value should be the delta for the movement. In this case, this will be our new acceleration variable. The move toward method makes sure that we don't move past our goal value, so we don't need to clamp this afterwards in any way. If the direction isn't 0, then one of the keys are pressed, and we then want the velocity to move from the current velocity towards the speed multiplied with the direction. Now let's test again and see how this feels. The player now needs to move a bit to reach the maximum speed, and it slides a bit when we either stop moving or want to change direction. Feel free to play around with the acceleration value until you find something you like. Now that our player can move left and right, it's time to add jumping and gravity. First, we want the player to start moving upwards when we press a jump key. In this video, we'll just use the UI accept action for this. This is set to enter and space by default. To move upwards, we first need to add a new exported variable for the jump speed. You can set this to whatever you like, and it is, as always, a good idea to experiment with this value as you continue to make your game. The important thing is just to make sure that this is a negative value. I'm setting mine to be minus the speed times 2. Down in our handle input method, we can then check if the UI accept action is pressed. And if this is the case, then we set the Y velocity to be the jump speed. If we test this, we'll see that the player now moves upwards when we press either enter or space on the keyboard. But we of course also want the player to move down again, so it's an actual jump and not some kind of flying we just enabled. For this, we start by adding a new method that we will use to update the movement each frame. This will take delta time as input. And then we call this from our physics process method right after we handle the input. In our new method, we will apply some gravity to the player so it starts moving down again. For this, we need yet another exported variable called gravity. It's important to remember that we don't want to simulate real life. Instead, we want to make something that feels fun to interact with. And we also don't measure distance in any real-life units, so the gravity shouldn't be 9.82 or anything like that. Just like with the jump speed, I actually prefer to make the gravity dependent on the speed. Here I'm making it 5 times the speed. Down in our update movement method, we can then apply gravity multiplied by delta to the Y velocity. This should keep increasing the downwards movement of the player. Being able to jump like this is already a lot more fun than only moving left and right. But you might also have noticed that we can just keep jumping even if we're in the air. To only enable jumping when we're touching the floor, we can use the character body's isOnFloor method. This method will return true if the last call of move and slide collided with the floor. What types of collisions that are defined as floor are dependent on 2 properties on the character body: the up direction and the max angle. Now, the player can only jump if the UI accept action is pressed and the isOnFloor method returns true. I still have a few neat tricks to show you before we end this tutorial, and we also need to animate the jumping, of course. The jumping has different animations for the up and downwards movement. But to make it easier to animate and to keep our code easier to manage, we'll first create a simple state system for our player class. Right now, our player can be idle, walking, jumping up, or jumping down. Each of these are their own state the player can be in. To keep track of this, we first create a new enum called state at the top of our script. The available values should then be idle, walk, jump, and down. Below this, we can create a new variable called current state. We'll then use this to keep track of what state the player is currently in. By default, this should be idle. I'm then also adding a new method called update states. This should also be called from the physics process method. Here we can then add a match statement that matches the current state. Okay, so if we are in the idle state when the x velocity isn't 0, then we change to the walk state. If we're in the walk state, then there are two cases to cover. If the x velocity is 0, then we want to change to idle. And when we walk out from a platform without jumping, then we have to change directly from the walk state to the down state. For this, we check that we are not on the floor and that the y velocity is positive. And then we change to the down state. If we're currently in the jump state when the y velocity is positive, then we also change to the down state. This happens when we are at the top of the jump curve and start moving down again. Finally, when we are in the down state, when we are also on the floor, then we change to idle if the x velocity is 0 and walk otherwise. Now we've updated our new state in almost all the required cases. There is, however, one state change that we can't handle here. We start our jump directly from the handle input method. So here we of course also have to move to the jump state. I hope these changes make sense, but please try to go through all the states yourself and make sure you understand when they happen and why we then want to change the state in those specific cases. And now it's easy for us to update our animation method. If the x velocity isn't 0, then we set the scale as before. And then we create a new match statement for the current state and play the corresponding animations. Our jumping should now be animated correctly, and we are ready to fine-tune our movement to make it feel even better. The first little trick we can add is to have two gravity values, one for when we're moving up and another for when we're moving down. I prefer to make the down gravity a factor of the other gravity, so I'm adding a new exported variable for the down gravity factor. And then down in the update movement method, we use the gravity to change the y velocity when we're in the jump state. Otherwise, we also apply the down gravity factor to the calculation. Now let's test this and see how it feels. Again, it might be a good idea to play around with the different speed and gravity settings until you find something you like. The two final tricks I'm going to show you will both help make the player less frustrated with the jump controls. Maybe the player wants to jump again right after it hits the floor. This can be really hard to time precisely, and there will probably be times where the player hits the jump key just before landing on the floor. And, well, as it is right now, that's just bad luck. So this can definitely lead to frustrated players, which in most cases isn't good. To make life a little easier for our player, we can add a jump buffer. First, we add a timer to the player. I'm calling this jump buffer timer. The timer node has two properties we need to set. First, it should be a one-shot. This makes sure that it only runs once after we start it. And then there's the wait time. This will be the amount of time the player is allowed to be early on the jumping. Tweak this as you like when we're done adding the jump buffer. Just make sure that this value is always more than 0.05. Now let's add a reference to the jump buffer timer at the top of the script so we can access it from our code. Okay, so the jump buffer works by starting the timer when we hit the jump key, and then if the timer hasn't run out when we hit the floor, a new jump is started. So let's start the timer in the handle input method when the UI accept action is pressed. Oh, and remember that the player doesn't have to be on the floor for the buffer timer to start. And then we don't want to start the jump here anymore. Instead, we go to the update movement method, and at the top, we check if we are on the floor and if the jump buffer timer has time left. If this is the case, we start our jump, stop the timer and set the current state to be jump. To test this and really see how it works, you might want to set the buffer timer to a higher value. Once you're sure you understand what it does, then you can fine-tune it to your liking. Timing is really something that can frustrate players, not only when they try to jump right when the floor is hit, but also when they jump out from a platform. Again, it can be difficult to time precisely, so here it can also be a good idea to give the player a little extra time to start the jump. We solve this with something called coyote time, and this works similar to the jump buffer. So let's add a new timer to the player scene. Make it one shot and set the wait time. This timer should start when the player moves off a platform without jumping. We can do this in our method for updating the states. What we're looking for is the case where we are in the walk state and change directly to the down state. This only happens when the player moves off a platform without jumping. So let's start the coyote timer here. And then back in the method for updating our movement, we then jump if we are either on the floor or the coyote timer has time left, and the jump buffer also has time left. Just like with the jump buffer timer, we then also need to stop the coyote timer here. Test this out and see how it feels. Again, you can start with a high wait time for the coyote timer to get a better understanding of how it works, and then fine-tune the value to your specific needs afterwards. We really covered so much in this episode. Now our platformer game has a player moving around and jumping with controls that feels fun. Please let me know if there are any specific platformer features you think I should cover in this series on how to make a platformer in Godot. I hope you liked this video, and remember to like, subscribe, hit the bell and all that if you want to see more like this in the future. Bye!